Well, good morning, good afternoon, good evening, good night to everyone, wherever you may be, somewhere on our lovely, hopefully green planet. Thanks for joining us live here for Serverless Office Hours. We're streaming on the AWS Twitch channel. Welcome if you're joining us from there. We're also on the YouTube Serverless Land page and also via LinkedIn Live. I'm Julian Wood, a developer advocate for Serverless here at AWS. And today, well, do you want to process streaming data at scale, efficiently? Well, today we have the stream for you. Sorry, I could not resist talking about the streaming kind of thing. And today we have two excellent people joining us. First of all, Joseph Moret from one of our awesome partners, Confluent. Joseph, tell us, well, I know you've even been at AWS before, so tell us what brings you to what you're doing at Confluent today.
Wow. How did I end up at Confluent? So I made the very risky move of taking a job in June of 2020, right in the middle of COVID, after working for a very stable company in AWS, simply because they were looking for a partner solutions architect that can own the AWS relationship. So when I saw the need for the AWS background, also having run Kafka myself, self-managed at a startup and knowing the pain that I felt with that, I felt like I was in a unique position to kind of bridge the gap between the two companies. And I got to say, it's been pretty fruitful. So I'm super excited to be here with you today, Julian and Mithun.
Cool, excellent. And yeah, Mithun, you're one of our great AWS's principal solutions architects. So yeah, tell us your journey to what you work on at AWS today.
Yeah, I'm part of the serverless team, and more specifically, part of the app modernization group, which includes serverless as well. And yeah, I've been here almost 7 years now, and covered a bunch of things. And most recently, covering a lot of things around Kafka and in general with stream processing. And of course, I've been partnering with Joseph on a lot of initiatives here with Confluent. So I'm glad we got this opportunity to present this to our customers. I'm really looking forward to it.
Excellent. So yeah, as you might have gathered, we're going to be talking a lot about Confluent and Kafka and all those kind of things, and something that I've been interested in recently as well. Yeah, super interesting space. That sometimes you think, oh, this is sort of an old style thing of streaming and all that kind of thing, and then you understand the scale, and you understand the power, and you understand, how relevant Kafka is and how serverless maps together. So yeah, we're going to be getting on that in a few minutes. But just looking back over the past week of serverless. If I get to the right place. Yeah, last week we had a cool stream with Josh Kahn talking about real-time web and mobile backends. Really fascinating stream because we talk about sync and we talk about async, and people think, oh, the async part must be slow. Well, this is really cool using actually EventBridge and GraphQL to have notifications to your mobile front end like really, really quickly, that you sort of think it's in real time, and makes that whole brittleness of often having a synchronous REST API just go away. So yeah, super useful. That's on our youtube.com/serverlessland, along with all other previous serverless office hours. So yeah, a huge bunch of content which is useful to look at. Nothing particularly new for the last week of serverless. Just before, I'd mentioned the week before with step functions with some elemental media convert. And in terms of blog posts, nothing hugely new this week as well. But in case you missed it, is all the things that came out from AWS Serverless in the first quarter of this year. Events coming up. It's AWS Summit season. The London Summit was last week. I think there were like 22,000 people or 22,000 people, which was huge. That's crazy. Yeah, free event. So they are free events, lots of great technical content. There's workshops, there's talks, there's partners to talk to and everything. So yeah, I suggest you have a look. I believe also there may be some more summons coming up. So actually I should check that page to update as well. But yeah, really great event. Great to meet lots of, if you're a customer on the customer partner side, it's a great opportunity to meet AWS people. And if you like us, you work at AWS, it's great to connect with lots of people in the community and answer your questions. Another thing happening in London on the 14th of May is Go to EDA Day. So this is Event-Driven Architectures Day, which is also pertinent to what we're going to be talking about today. So in London, tickets are, I think there are not that many tickets left. It's in a great venue, central of London, easy to get to. Did this 18 months ago. It was superb. Great session of talks happening as well. Also going to be talks on Kafka. So yeah, if you want to really get geeky on your event-driven architectures, that is the event to attend. But today we are talking about connecting Confluent to AWS. So maybe, Joseph, just to tie us up, tell us the sort of bigger picture and the story of Kafka and Confluent and how you see the world coming in. And before we do that, I should have done this before tying Joseph up. Just remember, we are live, so that, send us your questions, send us your comments. We'd love to hear from you, what you're building with streaming applications, where you're from. But yeah, over to Joseph.
So, I like starting with this really punchy slide, right? Most of you probably thought there weren't going to be any MRIs today, but in fact, there's at least, a little radiation coming from the stream. But no, in all seriousness,
I'm just wondering where you got my image from. I mean, that just looks like me.
I don't ask questions. I don't ask
Hell
questions. No. Let's start with this really audacious statement. Data streaming is the central nervous system for today's enterprises. What do we mean by that? Well, first, let's talk about what data streaming really is. Data streaming is about actioning on data as it ingresses and egresses through a data plane, through some middle layer, right? And we call it Kafka. So what is Kafka? Without getting into the detail, we will get into some of the details later as we get through the conversation, but I really want to kind of keep it high level for now. So Kafka is a system that allows you to handle events at massive scale. It's highly available, and it uses basically a producer-consumer model. Right, so things produce events, and then usually more things consume events. Usually, on average, 3x. There's usually like a 3x fan out, and this technology affects every single one of you, every single one of us, on a daily basis. Every time we interact with Netflix, that's going through Kafka topics. Every time we order a ride share, or we order food from, say, Uber Eats, all using Kafka. 10 out of 10 of the top US banks are Confluent customers. Because why would they need, what is common about those services, right? Massive amounts of data that are highly dependent on ordering, exactly want semantics, idempotence, and scale and high availability, right? And financial services are always kind of at the forefront of new technologies because, one, they got a lot of money. There's a lot of investment in technology. And they were very early on with Kafka specifically for those reasons. So that's kind of the core of what it was built. But as the word connect implies, there's much more to that as we kind of dive through the various APIs that are connected to it. And then the other question, and this kind of begs the question, is who is Confluent? So let's talk about that for just a moment. So Confluent, the company I work for, our founders were the original developers of Apache Kafka. So they worked at LinkedIn many years ago, pre-Microsoft acquisition, and they ran into this problem. They had databases and they had message queues. And the problem they had with message queues is they didn't have persistence. Right, so they were really fast and they allowed things to consume an event and that event would disappear. But they had use cases where they needed to ingest events at different frequencies. So they had some microservices that were in real time, but they also had some micro batches, because this was years ago and you just couldn't get away from batch technology. So they needed something that had a persistence layer like a database. Now, databases are great, but they're generally optimized for really massive ingestion or massive consumption. It's very difficult to have a optimized database that can handle massive writes and massive reads. Hence the genesis of Kafka, right? So something that works similar to a message queue, but has a persistence layer that we can commit to disk and we can read that event hours later, days later, and in some instances, years later for compliance reasons, right? And think about those highly regulated industries where you need to have a statement of record that goes back 7 years. Hence the genesis of Kafka. So our founders eventually left LinkedIn and started a company and started building what we call Confluent Platform today, which was a self-managed offering of Kafka. And it has some really nice bells and whistles that were gaps in the open source offering. And today we have a really incredible product called Confluent Cloud that runs on AWS. And it's our SaaS offering. And we're going to be talking about how that kind of differentiates from Confluent Platform and open source. So that is, I said a lot there. So I'm going to take a pause and see if you have any responses or questions as we continue on.
Yeah, I think that's really nicely framed. I like hearing the combination of a message queue and a database with the two use cases and bringing them together. And yeah, I think, ordering in a high scale is the other kind of thing that always that comes to mind. It doesn't have to be ordering, but you think of the example of using Slack or some sort of chatbot. If you have to play those messages out of order, that can just be silly. Yeah, the ordering is certainly important, and I think the scale is impressive. I mean, you think of IoT buttons or clickstream data on websites. This is high scale. You could certainly do lots of data in a database or the message queue, but the scale sort of does that. And yeah, Kafka is interesting. I mean, it is old, but it's not that kind of old. And so I think it's incredible that, because I think it's 2010 or 2011 or sometime
That's
around
right.
that
That's
amount.
exactly right. So we're coming up on its 15th birthday.
And the fact that it's open source and widely used everywhere, I think it's also a hugely successful rallying cry for open source. This is one of the great big data platforms in open source.
Yeah, it's one of the top Apache software foundation projects. Absolutely.
Cool. And then, Mithun, how are you seeing the customers that you work with use Kafka? I mean, what sort of use cases or sort of cool things that they do that you think is interesting to share?
Yeah, no, absolutely. And in addition to what Joseph said, I see customers using it a lot, very frequently, with use cases which involve data replication, bringing data from all sorts of their traditional data sources, instead of doing them as batch workloads, as Joseph was talking about, right? They were time consuming, resource intensive. Instead, they're now moving more towards more near real time patterns, where the data change events are simply streamed through like an event bus like Kafka, and then populating other data stores which are more organized as microservices and have their own local replicas. So populating those data stores, it's used very commonly for exchanging events between microservices in an asynchronous manner, using the traditional pub sub model. We'll talk about like how EDA builds on top of it as well. Plus, for some of these IoT type of use cases as well, where you have devices sending massive amounts of data, and you want to capture them in your real time and populate them, create visualizations, and so on. Kafka just fits in very, seamlessly with those use cases as well. So yeah, those are a snapshot of what I see. There are more as well, but I think those are very commonly used.
Thanks. Yeah, and I think that part of the interesting thing about Kafka is it's not just an on-prem or a data center or a cloud technology. It's literally used absolutely everywhere. And I think part of the story, and I think what I understand what Confluent brings to it, is that bridge between an on-prem and the cloud, a sort of hybrid approach. And we've had streams previously where you integrate Confluent with EventBridge and Confluent with Lambda, and we're going to talk about a whole lot to that today. So Joseph, just give us a sense of what the story is of, because you are talking about connecting data. How does this connectivity work when you maybe have data everywhere, or you have a big you're a bank and you have big on-premises data centers, but you want to leverage the cloud?
Well, you kind of hit the nail on the head. So when our founder started, Confluent Platform was simply, even before Confluent Platform existed, Confluent existed helping customers build, highly performant Kafka clusters on premise. So it started absolutely on-prem, and it made its way into the cloud, like many other software vendors out there, any other ISVs. And again, we can run Confluent on something as small as a Raspberry Pi, or on something as large as the largest, or a physical server, bare metal server that you have, either in your cloud or in your data center, and kind of everything in between. And it creates this really unique scenario where you have this protocol, right? Because Kafka at the end of the day is a protocol, right? Kind of the infrastructure under it's all kind of the less interesting bits of it, but the really interesting bits of it are, federating data across a global estate, right? Having pockets of data in different geos, and maybe even in a banking scenario in retail stores or in retail bank locations, and then tying all that together. And there are some open source technologies that allow you to replicate something in particular called Mirror Maker. We have a legacy solution ourselves. It's still very, very popular and very battle tested called Replicator, which is built on top of Kafka Connect. We'll be talking about Connect in a bit. But the latest and greatest is something called cluster linking, which we'll be talking later. It is proprietary to Confluent, but it actually, what it does is it extends your Kafka clusters or extends your data across multiple clusters. And it uses the internal replication mechanism of Kafka. So Kafka, we haven't talked about this yet. And let me just advance my slide because I think it adds something to this. So I forgot there was that little bit there that was just waiting for me. You have, you have topics, right? This is the logical collection of events. So you may have a inventory topic. You may have a customer's topic, right? And to make it performant and highly available, what we do is we use what's called partitioning. So we take that data, we split it up into multiple partitions. And the more partitions we have, the more throughput that provides us. And then what we do is we copy partitions across brokers. And those are called replicas. And then each partition has a leader. And that allows us for high availability. So if a broker were to fail, we have replications of the partitions that broker was the leader for. And now we can have one of the other brokers promoted and then handling the traffic until we can replace that broker. That's the high availability. With cluster linking, we take that same paradigm, but we can split it globally. So now a cluster that's sitting in US East 2 and a cluster sitting in US West 2 can also have their topics extended across for DR scenarios, for fan in, for fan out, a lot of really fantastic use cases that can provide us.
Okay. So let's not just talk about some of the integrate. We've got some of the connections, because obviously we're talking about serverless connections over here. The ones I can think of the top of my head is, I know on the slide there you've got Kafka Connect. So this is a way when you sort of push data to, or pull data and push data to different kind of systems. So I know Kafka Connect can push to AWS. I know that AWS can then pull data from Kafka, and they, multiple ways they can do it. EventBridge pipes comes to mind, Lambda comes to mind. So how does one, how should one think about choosing how to consume Kafka data? And I mean, even, I know we're on serverless office hours, but like, is serverless a really good approach for doing this, and why would that be?
Yeah, you know what? Let me. I think we actually have a specific slides here. We talked about this, right? Kafka 4 features: publish extreme events, store your events, and process and analyze them. Let's skip over this one. I think I covered most of these. I also covered this as well. So
the Confluent platform, that's the on-premises one. We'll run it on EC2, and then the Confluent Cloud is
our
Apache
fully
Kafka
managed offering, right? It's the self-driving car. That's why I like to think about it, right?
And
so
you've also rebuilt Kafka to do that. So I mean, you're not actually quite running necessarily the open source, because you've optimized it to run at ridiculous scale in the cloud as a sort of multi-tenant SaaS platform. But obviously, it's all Kafka.
That's exactly right. I mean, think about what AWS did when they built their cloud offering. They took a bunch of commoditized hardware, right? A bunch of servers and network gear and storage, and they abstracted it. And there's a system, no one really talks about, but there's a system that AWS built. It's massive, that handles all the management and the APIs that allow us to interact and do all these fantastic things. Yeah. We did the same thing for Kafka. We built Kora, which is our backend system that allows us to bin pack and auto scale and truly decouple the storage layer from the compute layer, which is essentially at the heart of what serverless is. So that's one of my favorite things of interacting with Lambda is I feel like you have serverless compute meets serverless data streaming, and you have all these wonderful advantages. As I know, Julian, you're a former ops guy, so am I. These type of practices keep us from waking up at night because of scaling issues, because of reliability, just all the fantastic things. And if anyone out there really wants to nerd out about Kora, we have a paper out there called Kora, a cloud native event streaming platform, which won best industry paper last year at VLDB. So if you really want to know how much effort, millions and millions of man hours that went into building this backend system that truly differentiates the SaaS offering of Confluent Cloud from just running Confluent platform in EC2 or in EKS, I highly encourage you to do that. But getting into the theme of connectivity, this is exactly what Julian was talking about. So in addition to the produce and consume API, there's the streams API, which we'll talk about in a bit, and then there's the connect API. And as Julian mentioned, the Connect API allows us to source data from things that aren't Kafka, like S3 or a relational database or a mainframe, and then do the opposite, where we can sync data into systems like MongoDB Atlas, Snowflake, Databricks, S3. We can actually have source and syncs for S3. Interesting stat. Confluent customers pushed an exabyte of brand new data into S3 in 2023. And I think we'll be closer to an exabyte and a half this year. So massive amount of adoption with S3 and Confluent, but specifically thinking about beyond Connect, right? So Connect allows us to run these processes that basically emulate a database reader, right? Or a S3 writer. But there are native integrations because, as I mentioned, Kafka is a protocol. It's a very attractive, very popular, and awesome protocol. And AWS has built some native integrations. So EventBridge, EventBridge pipes, Athena, IoT Core, Lambda, I'm sure I'm forgetting one, OpenSearch, all have native Kafka integrations. So you simply point it at your Bootstrap servers, right? That's the URL essentially that allows Kafka producers and consumers to know where all of their brokers are and connect all the metadata they need to make those connections. You provide it with authentication. And depending on which service we're talking about, you're then natively consuming or natively producing events into Confluent Cloud. So you have the freedom of using Connect, or when it is available, I tend to steer people towards the native integrations because I believe that is ultimately the future. I think, considering it's only 11 years old, I think at its 20th birthday, we will see the most prominent data sources and things all have native integrations with Kafka, the protocol, which I think in the long run is nice because, the Connect is great, but it's another layer to manage. Ultimately, we want things natively consuming and producing, but this does allow you to have really outstanding outcomes, especially for enterprises that are still hybrid. So, how could you take a mainframe and use it as an event source for a Lambda function? The answer is Kafka, right? And Confluent. You could have Confluent platform running in a customer's data center, running a connector that sources events into that local Confluent platform cluster. You can use cluster linking to take that event into Confluent Cloud, and then you can have the event source mapping of Lambda consuming that topic. So you could really run the gamut of technologies, right? You can have something that is 75 years old, a mainframe, sending data to, the most abstracted compute layer that I can think of in Lambda. And I don't know, tears come to my eyes when I think about how powerful that type of solution would be.
Cool, excellent. Just before, because Mithun, I just want to ask you, let's start with the EventBridge integration, and I know you've got some interesting stuff to say that as well. But we did mention this bit before, but I think Apura TV wants to also, what do you mean by Kafka being a protocol? What does that mean? Thanks for joining us via Twitch, by the way.
Yeah, that's a great question. I mean, so Kafka is essentially its own protocol, right? It doesn't run, obviously it interacts with the TCP/IP stack, but it's a protocol for consuming and producing events into this decoupled system, right? When I think of well architected, right, and I think this is all drilled into our minds as AWS solutions architects. Loosely coupling apps or loosely coupling data and sources and destinations is a goal, right? When you have things directly, your Microsoft services talk directly to each other, that can be brittle and it doesn't always scale. But by having a middle layer, right, having your front end microservices produce events that can, as Mithun mentioned, could be asynchronously consumed by backend services. Having that middle layer that is there, whether you're rolling your upgrades or doing something like that, is very attractive, right? And then when you think about Connect, you can now have Kafka or Confluent be the middle layer for all of your data estate, and kind of take some of that weight off of your massive RDS clusters, right? And not everything has to read right from that RDS cluster because we have the events in Kafka. Okay. But it's a protocol in the sense that how we deliver the underlying storage and compute is almost immaterial to what the outcome is. And the outcome is I want to be able to consume data and I want to be able to produce data. And the Kafka protocol, which is his own protocol, is really what is the unifying piece of that. So whether you're running open source or you're talking to Confluent Cloud, the underlying technologies or the physical layer is much different, but the protocol is the same. It's backwards and forwards compatible, which means that, even if you're running an old set of consumers or clients, you would be able to point them over to Confluent Cloud because it's forwards compatible.
Yeah.
I hope that answers the question.
Thanks. Well, thanks, Improved TV. Hopefully that helps. And just a quick one, because I know we want to get to a demo, because we always want to see how this works. So the Donut85, thanks for joining us via Twitch. When you say Salesforce, do you mean Force only or all Salesforce systems like Commerce Cloud?
So we do have a Salesforce connector, and I want to say, hold on one second, if I can bring this up. I'm not sure exactly which of the connectors or which of the services it connects to. I know it connects to Salesforce.com, but I am far removed from being a Salesforce expert. So outside of that, I didn't even know there's a whole bunch of different things.
No. Thanks. Well, the Donut85, we'll see if we can find that for you. So just Mithin, can you chat to us about EventBridge, how that sort of works, how the two services, Kafka Confluent can complement EventBridge, and a little bit about EventBridge pipes.
Yeah, so we see Kafka or Confluent in particular playing a key role in being that front end or that first layer of interaction when you're getting like streaming data in, which are sort of coming in at a high velocity at a massive throughput. So that is where we want to use a streaming service like Kafka to ingest those events in. Whereas the part where EventBridge really adds value is being able to route some of those events, not all of them, but some of those events where a certain business process needs to be triggered, right? For example, I talked earlier about IoT data, right? Or for that matter, change data capture as well. So let's say if those events are coming in and you want to react to those events either in the form of aggregates, maybe let's say if there is a vehicle that you're tracking, right, and that those events are coming through in a Kafka stream, but let's say in a period of 5 minutes, suddenly you don't get an event from a particular vehicle, and it may signal some kind of an anomaly, right? Maybe that vehicle has broken down, maybe there is something wrong, maybe there's a driver distress or whatever, right? So, and in those situations, you may want to reach out back to that vehicle in some shape or form. This is where the two services can play a role, meaning that the ingestion events of the GPS location or maybe the odometer reading or whatever it is, those are coming through a Kafka stream. Then in middle, you have something like a Kafka Connect, or basically a sync connector going into EventBridge or pipes for that matter, being used to specifically filter out those type of specific events, sending it into EventBridge. And EventBridge in itself doesn't give you a percentage. It has an archive feature, but if we leave aside that part, it is very efficient in terms of routing those events to specific AWS services. For example, you can say that if the reading on the odometer has gone beyond something, I want to trigger AWS step functions workflow, which can then do multi-step processing, maybe have somebody look at a dashboard or something like that. So that's where EventBridge really comes very handy, and it adds value to it. And as you pointed out, there are two ways you can do this. One, using EventBridge pipes. EventBridge pipes in itself is more for point-to-point kind of integration, meaning going from a Kafka topic to an SQS for example. Then EventBridge pipes is very good. And then obviously the Kafka Connect piece, which you said, which is a sync connector, which just puts the events back into an event bus using Kafka Connect's infrastructure.
Okay, so people should think about EventBridge pipes as a sort of source to destination. I know you can do a little bit of a transformation, but
Right.
this is for, you have a Kafka topic, you're filtering, or potentially filtering, you can filter, say, on that odometer value, maybe doing some small sort of transformation and then sending it on to another service. And those are all the services that EventBridge pipe supports, as well as any API on the internet. So I know this can be a circular pattern where you can then send that data back to Kafka because it can be consumed by somewhere
Right.
else. So is then EventBridge pipes the easy, fast to get going, sort of simple way to use things?
Exactly.
And we're going to talk about Lambda later on. Should people think of, if they need to do, bigger data crunching or bigger data analysis or something like that, or a target that EventBridge pipes doesn't support, then they think about Lambda. I'm sort of trying to work out, where the sort of gray areas cross over.
Yeah, no, you're right. EventBridge pipes, as I said, is an easy serverless way of creating these integrations between a Kafka topic and AWS services in particular. That gives you that very easy way to connect the two. In between, you can have some enrichment via an external API call or a Lambda function to do, some of the transformation, and basically the output of that is sent into the destination. Whereas when, let's say, we have a customer who's invested in Kafka Connect, right? They have those resources and they want something specifically with Kafka Connect, for example, then obviously the sync connector that we talked about can be used. But the most easiest way to bridge this gap is using the pipes functionality.
Okay, excellent. And Joseph, you were going to say something there, and then I.
Yeah. So to Mithun's, IoT example, I know of at least 2 EV makers that are trying to do that very same thing with Confluent and AWS today. So you very much hit the nail on the head. To provide predictive maintenance, collision avoidance or detection. I mean, there's so many reasons that you'd want to have that because you can leverage massive machine learning models in the background that you wouldn't want to run in a car, but you could still feed the data to detect some type of anomaly. There's a ton of advantages to that. And just to kind of circle back to the Salesforce question, our connector supports the Salesforce streaming API and the Salesforce enterprise messaging platform events. That was going to kill me if I didn't do that.
Cool. Thanks for looking that up. Cool. So anything else we will need to say about the EventBridge? Oh, what I did want to say is we do actually have a previous stream, which wasn't about Confluent, but it was about Kafka itself, which is obviously Confluent is entirely compliant with that. And so this was with Dave Boyne and Michael Gash. Michael Gash is also a Kafka expert as well as an EventBridge product manager. So this is a previous stream we had, and he had a really cool demo where it was Kafka running on his laptop, and he was sending messages through Kafka, through EventBridge pipes and back onto Kafka. So yeah, that's a whole big demo. I've got it on the screen. Excellent.
Yeah. And to this day, Confluent, we're still major contributors to the open source project as well.
Definitely. So. Cool. Excellent. Joseph, should we switch over and talk about a bit of Lambda? Because I know you have a demo and I don't want to run out of time because
I did want to talk about, I just have a couple more slides if you don't mind getting through. I did want to talk about this concept of shifting left. So if you can bring up the presentation, I'd appreciate
certainly.
it. So the other API I talked about, and we haven't talked about in detail, is the Streams API. So the Streams API allows you to build these things called Kafka streams in either Java or, let me say it right because I always say it wrong, Scala, not Scala, Scala, which is actually very popular, especially in financial services, right? So these are essentially microservices that have Kafka streams injected into them, and they allow data to be manipulated in real time. So you may have an input topic that takes raw data, does some type of transformation, writes it back into another topic. And then we had another system called KSQLDB, which was an abstraction layer on top of that, because I'm not good with Java or Scala. I'm pretty dangerous with Python. But it allowed database administrators that were very used to using SQL and CRUD statements to build very similar type of streaming applications. And the future of stream processing at Confluent is Flink. So a year and a half ago, we made an acquisition of a company called Immerok, where most of the Apache Flink committers worked. Now they all work for us. And that's why I kind of think of Confluent as more than just Kafka now. I think of us as the data streaming and stream processing company, right? Independent of those projects. We still pay homage and we still respect the fact that we're built on top of open source, but now we've kind of made this really beautiful combined package where you can easily incorporate stream processing into on top of just your consumer and producer model. And we allow what we call it a shifting left. The idea is that let's move some of our pre-processing into Confluent Cloud, because as Mithun mentioned, you don't necessarily want to process all of these events. You may not want to pass, you may be doing 100 million events a day, but you may only want to pass 10 million of those over to Lambda for whatever function you're running. And Flink can help with filtering. It can help with data merging. So let's say, for example, you needed data from a database and data from a RabbitMQ. And you needed to combine that data before you send it to the function because it needs both, it has disparate data sets. Confluent can help you do that, right? With our connectors, we can bring the data into two different topics, and then Flink would help you easily stitch those together on some common field. And then we would have the Lambda ESM sitting on top of the output topic. So it really gives you some fantastic outcomes. And then the other piece of this, and I won't dive in too much, is data governance, right? Data quality. So we have a whole set of data governance tools that allow you to ensure that the data that is coming into the events is what you want. Are the right fields there? Are the fields correctly populated? Where did this data come from? Does it have the right encryption? All these things, and if they don't, we can reject that data. And to me, that's where you want to fix you want to have your data clean at the entrance. You don't want to wait till it gets to the back of the bar before you're cleaning things up, right? You want to you want to have that bouncer there in the front that says, "Hey, you don't come in here. You don't meet the dress code." So that is stream processing, and I would be remiss.
So people should think about the stream processing part of it, the Kafka streams, as the sort of engine of moving data around. And it's about partitions, it's about scale outs, across clusters, as you mentioned, all this clever stuff to get data from A to B. And then Flink is the sort of the processing of that, the analyzing the data, the merging, the splitting, the doing stuff with that data. Possibly what you maybe sometimes use a Lambda function for, but
Absolutely.
Now Flink allows you to do that sort of as part of the same platform.
There are certain things that Lambda and
it's going to be different. Of course,
libraries just make bricks simple compared to trying to do it stream processing. But basically, I say do as much as you can with Flink until you can't, and then use Lambda. That's to me like a very ideal way of building things. And in my demo later, I'll give a very novel example of exactly a scenario that is brick simple to do in Lambda, but would be very challenging to do in Flink. So we already talked about cluster linking. I won't continue to dive in there. So let's talk about Lambda. So there are two options for integrating Confluent with Lambda. So one is the sync connector, which is very popular. Again, it runs on top of Kafka Connect. We do offer it as fully managed in Confluent Cloud. So you basically just give it your Lambda's ARN, you give it the right authentication, you point it at a topic, you're good to go. But the other side is the native integration, and this is the one that gets me very excited, and that's the event source mapping. So the event source mapping, all Lambda functions need an event source, and Kafka is one of the polling sources. And the really only downside to the event source mapping is it doesn't support asynchronous work or asynchronous invocation. So Julian, I know you mentioned a very interesting previous serverless session that was about asynchronous invocation. So if you wanted to, combine Confluent with Lambda asynchronously, the connector would be the way to go. The other scenario where I think connector has its advantage is when you have very, very bursty traffic, meaning things are changing, your data volume is changing by orders of magnitude per minute. With the event source mapping, because it uses it auto scales, that would cause a lot of consumer rebalances, which would affect performance. So, but again, that is 1 out of every 100 use cases. Yeah. So 99% of the time, you have this beautiful event source mapping. And what it does is AWS spins up consumers for you, and they consume from Confluent or any flavor of Kafka. And it auto scales, and AWS assumes the cost of those consumers, whether it's one consumer or 100 consumers, basically defined by your concurrency and by the number of partitions in that particular topic. And it will track how far it's lagging, the offset lag, between what's current and where it is in its consumer group. And if that number is growing, it'll auto scale and it'll add more consumers until it hits the max number, which would be the concurrency. Well, no, I'm sorry, which would be the number of partitions. Or it'll scale down. So if you have 50 consumers and the lag is going nowhere, it'll start to remove some of those consumers. So it's really beautiful in how it handles the connectivity between the throughput and then the high availability.
And Joseph, how much does the event source mapping cost?
Zero. You're not paying for the event source mapping, you're paying for the invocations of the function. So as Julian makes a very salient point, with the filtering aspect of the event source mapping, you could theoretically be consuming hundreds of thousands, if not millions of events in a day, but only pay for a 10% of that, because only 10% of our events are going to trigger the Lambda function, and those invocations are what you're paying for. So from a cost optimization standpoint, and I used to be an AWS TAM, so this is near and dear to my heart, it's a very incredible value proposition.
Yeah, no, I love the event source mapping. Basically, sucks data out of Confluent and then can do anything in Lambda that you can that Lambda can do. So yeah, very powerful. Lots of functionality that it can do from the filtering. Batches things up, so that makes things even more efficient.
Yes.
You can decide where you're going to start in the stream. Just if you're using your Kafka or your Confluent goodness, this is actually a really easy way to consume. And also the cool thing about the event source mapping is that's a Lambda managed resource. So obviously Kafka is very heavy in the Java world, which is super cool. But sometimes maybe you've got teams that don't necessarily know Java, or they're not that comfortable with it. And so because the event source mapping is a Lambda resource, which is going to do all the polling in, we don't even care. I presume it's Java. I don't even know, actually. It's going to pull all the data from Confluent, send it to your Lambda function, which can be run in any language. So you can literally have a Lambda consumer that's in Go, Rust, Python, Node, of course, Java. I mean, you could do it in PHP if you want, literally any language you want. And I think that's a super flexible thing that sometimes people don't think about, is it allows different teams within your organization to use the same data in other programming languages that they are familiar with.
Yeah, to take that a step further, because the ESM is doing the consumption, and as you mentioned, the Lambda has no idea that it's talking to Kafka. We have a REST proxy for produce. So you could make your Lambda, let's say you had you wanted to consume, transform, and then write back into Kafka. You could hit a REST endpoint, and at that point, your function has no idea it's talking to Kafka. It's completely ignorant of that. Or you can import one of our, so we have clients for all the major, software languages that anyone would want to use. Many of them that you mentioned already. So you can plug in the produce library as a layer, and then simply, produce natively to Confluent if you have that use case.
Yeah, cool.
Yeah. So I think I have something that is relevant. So this one I really like to show, because this kind of ties it all together. This is not architecture, this is marketecture, but it does give a really nice visual. If you follow that nice, thick orange line from the left side. So this is exactly the narrative I showed earlier, where you would use a connector on premise using Confluent Platform. And you want to use that on premise because you probably have still on premise workloads that you want to offload from the mainframe, because mainframe time is very expensive. So you have that. You have cluster linking across an AWS DX or Direct Connect that privately can bridge that data. And now that mainframe event is living in Confluent Cloud, and either using the sync, which we feature here, or the ESM, we can have Lambda consume that event and then do something amazing with it. So I actually really love this picture, because you could basically use a Lambda function with any of your legacy data estate as you're, on that cloud migration journey. And as we know, with big enterprises, this is not a 1-year effort. This is a multi-year effort, but you could start to get value out of these fantastic AWS services now while you're still modernizing and migrating. And moving on, I think, okay, so here is the setup for our demo. So let's move on to that. So I'm going to be using a synthetic producer. I have a Docker container that is going to be producing events into 3 different topics in Confluent Cloud: the online topic, the retail topic, and the third-party topic. And in this scenario, let's pretend we work for a bank, and our bank needs data normalized before some downstream system can use it. And we're going to use Lambda to do that data normalization. So what do I mean by data normalization? I mean that we can't have camel case between our words. Words should begin with an uppercase and then the rest should be lowercase. We don't want any leading spaces or trailing spaces. And we have these 3 different sources. So we have our online topic. So this is coming from our website. Fortunately, our website has data normalization built into it. The fields will auto-normalize or they'll reject the submission and the user has to fix it before they can submit it. So we don't have to worry about that online topic. It can go right to the final topic where it's going to be consumed by something that's brittle that can't handle unnormalized data. We can pretend what that thing is. It could be something. We also have the retail topic. So these are our stores. So there are our branch locations. Now with those, we have older versions of the point of sale system or the point of servicing system out there in the wild. And we know that the older versions don't have built-in normalization and the newer versions do. So we're going to use a KSQL DB query to look at the metadata of the event. And if it's the old software, we're going to send it to the Lambda function to be normalized. If it's the newer software, we're going to send it right to the final topic. And in the third case, we have a third-party topic. So this is from our partners. And we can't trust that they're going to normalize their data, so we have to do that. And they also send all of their data in a nested field. So we need to unpack that and break it into separate columns before we send it to Lambda, before it will normalize and then right back into Confluent. So let me break out of this for just a moment, and we're going to log into Confluent Cloud. And I like doing all this live because I want to show you how easy it is to use our UI. And how powerful it is. And I'm going to move over. Okay, very good. I'm going to move over just a second. You can't see what I'm doing, but I'm starting my Docker file in just a moment. So we have multiple environments here. So again, this is Confluent Cloud. Environments, think of these are collections of clusters. This could be dev, staging, and prod. This could be, I don't know, business unit 1, business unit 2. We have long-term demos, which I ask people not to delete, including one of my favorite demos, this Lambda demo. And right now you'll see that there's really nothing coming into our topics. Everything is 0 because I've turned everything off. So I'm about to turn everything on now. And there we go. And we do have an event source mapping set up for the normalized topic. So data that's going to make it into the normalized topic is going to be consumed by the Lambda function. It's going to be normalized. And then it's going to be written into the final topic where some brittle system that can't handle unnormalized data is going to live. So let's take a look at our online topic to show you an example of what unnormalized data looks like. So let's see. I'm usually pretty good at finding one of these within a short amount of time. It's going to make a liar out of me. Let me actually see. Where is the other? I'm sorry. I'm on the online topic. Wrong. The online topic is good. There's no bad data there. That's fine. So let's go to the retail topic where there's bad data. And did I find one? No. Okay, there we go. So here's a good example. So you can see the city is in all lowercase. That's not good. And we have a bunch of trailing spaces. That's going to break our downstream system. The state is in lowercase instead of uppercase. So it should be, this is North America. This is the US. So it should be okay for Oklahoma. That trailing space is a problem. So this would be problematic for our system. So we have an event source mapping. Well, actually, before we get to the event source mapping, let me just show you quickly KSQL DB. I need to update this demo to use Flink because that really is the direction we're going in. But we have these persistent queries here. And then one that is very helpful is the unpack. So in the third party, we have everything nested into one field. This is what's going to explode that one field into multiple fields, applicants, deposit, et cetera, et cetera. So that's a pretty powerful one. We also have a query here that this is the one for retail that basically says if the software version is newer than 5, it's 5 or newer, send it right to the final topic because we know that data is normalized. And then we have another one in here somewhere that basically, is the opposite of this. That's going to send everything that's older to the normalized topic. So we're doing a little bit of data routing, but that's it. We're not doing any merging or anything special. We're letting the heavy lifting happen by Lambda. And the way I can show you this without actually going into the console. So we have an event source mapping. You can take my word for it. We have this fantastic feature called stream lineage. So stream lineage allows us to see where are our consumers, where are our producers, what are our transformations, whether it's Flink or it's KSQL DB or Kafka streams. And let me just zoom in here. So we see we have a producer that's producing into third party, right? We talked about that narrative. We have our producer one going into the retail topic, and you'll notice there's a split of data here, right? Because of that version of software of retail. So the newer version of the software is going to go directly into the final topic because we don't need to normalize that. The things we do need to normalize are roughly half of our retail will go into the normalized topic. This is where the Lambda is consuming events from. And then all of the third-party topic or events after being unpacked will go into the normalize. And then normalize is being consumed by a custom app called AWS Lambda. Now, what is this? This is the consumer group name of the ESM. So we name the consumer group AWS Lambda, and then also in the Lambda code, we're using, in this case, I think we're using Python, or we're using our Python library. We can give a client name as we produce, and we give it the same name of AWS Lambda. And what Lineage does here is it sees a consumer called AWS-Lambda and a producer called AWS-Lambda, and it treats it as a custom application, which is great because you get to see it consuming data from normalize and then writing that data into final. And all of these links here are clickable, and they allow us to see how much throughput is happening. And you know, the numbers look small because it's over like 12 hours and I just started the data. But if this were a production system, you would see nice peaks and valleys. We can click on the app itself and take a look at the consumers that are associated with it, the producers that are associated with it. We can also take a click into one of these topics and see the metadata associated with it, the schema of it, and then the messages that are coming through. So to kind of just wrap this up, let me go back to the final topic. Oops. And you'll see now we have production and consumption here because there's actually data flowing through it. And in the final topic, if we take a look at the messages, we'll see that all of them are beautiful and clean, and none of them have unnormalized data, which is exactly what we want, right? Because Lambda, so again, to do this in KSQLDB or Flink or Kafka Streams would be quite a challenge. Streams wouldn't be too bad. But it would be overkill. But in this case, with our Lambda function, we just imported like, I think 2 libraries to do this. And it was simply as feed this in, you know, set your caps for your first letter, remove any trailing or leading spaces, write back the data right back into this other topic. And it's a very simplex scenario. And again, we're using a container to produce this data. But our retail topic could be coming from a source connector hitting an RDS database. Yeah. Our third-party topic could be coming from an SFTP file using our SFTP source connector, and our retail topic could be coming from some RabbitMQ or something that's legacy. And all of this can be done. So as our viewers are thinking about how could this combination of events, connectors, and Lambda enrich my use cases, think about what systems that are out there today that you don't have direct access to or you wish you had combined access to. And consider using something like Confluent technologies to bridge that data, put it in a single place, now giving it access to something like Lambda or EventBridge or any of our other partners. So we have this program here called Connect with Confluent. Lambda was our first cloud CWC partner. Athena was our second. EventBridge was our third, and OpenSearch will be our fourth. So I'm very happy that my partner is participating in the program, and all of these outcomes are possible to you once that data is in Confluent Cloud.
Okay, excellent. Oh, well, thanks, Joseph. I just want to, Mithun, we've got a sort of another minute. From what you've seen and what you know about Kafka and Confluent, how can people take this forward? What's some sort of actionable things or things that people should think about or they can take advantage of that maybe they don't know and can sort of spark those brain neurons to do more with Confluent?
Yeah, absolutely. So I'll try to keep it short. So basically, one of the biggest benefits, which we briefly talked about with using Lambda for processing these events coming in through the Confluent Cloud, is the compatibility with multiple programming languages, right? So you're not really bound to use Java or Python, whatever the Lambda ecosystem supports. You can use any of those languages and you'll be just fine, because the Lambda ESM does that heavy lifting of polling through the Kafka topics and handing over those messages to your Lambda function written in whichever language you choose, and then you can do that processing. Not only that, with respect to the Lambda integration, we have this concept of filtering events, meaning that as long as your data is in a JSON structure, you can write expressions which specifically allow you to selectively get those events and trigger your Lambda function, and you can do batching. And those batches are created post the filtering. So you're never, charged for any invocations which are not resulting in
That you
any
don't.
kind of a meaningful processing. So that's a big benefit customers can think about in terms of using Lambda for these use cases. And then the other part is basically the auto scaling capability, right? Instead of you thinking in terms of how many consumers I need to provisioning capacity for that in a traditional way, you let Lambda do that scale out and scale in based on the volume of data that's coming in through the Kafka topic, and that's all built in, and you can even keep track. Through our CloudWatch integration, you can see what is the backlog and so on. Basically, and even if you repartition your topics and things like that, the Lambda ESM will take care of it. It
And just
allows
figures
you
it
to
out.
do, yeah. And I will just two more points. One is basically the concept of on failure destination. So previously with Lambda, we had a limitation that if there is a message or an event which causes your Lambda function, to throw an exception, your function would be responsible specifically to sort of log it and return a success so that you can move on to the next record. Now we do have a capability where the Lambda service itself will do like a best effort retry, and in spite of that, if there is exception coming in, it can put those records into either an SNS topic or an SQS queue or even into an S3 bucket. So that's a big benefit for customers where they don't need to no longer think about how to handle those type of situations. And then we also support a concept of a consumer group ID. So let's say if you have use cases where maybe you are processing data from a Kafka topic in a traditional, like an on-prem data center, but now you suddenly get a spike of data coming in. You added more partitions to the topic, and you want to burst onto the cloud for that for processing. Lambda in those use cases can be very efficient by when you can just simply have a consumer there. You specify the same consumer group ID that maybe your on-prem consumers using, and you've now created a burst capacity
Perfect.
on the cloud.
Excellent.
So those are some
Mithun,
very
yeah.
key points.
Thank you very much. Our time is sort of up, unfortunately. Thanks so much for joining us. Next week, we're talking Gen AI. We've actually got 3 weeks in a row, which we're going to be talking about cool AI and ML kind of stuff. Next week, it's Ruben Fonseca talking about code stuff and orchestration stuff to be able to integrate Gen AI agents using a serverless approach. Joseph, Mithun, thanks so much. I appreciate your time today. Thanks for dropping all your good wisdom, and everybody else.